Move on in chapter 6 of Algebra 1, least common denominators. So now we're going to find some equivalency. We're going to practice that. If I'm given a fraction, can I find an equivalent fraction with a different denominator? And this is just multiplication. You are finding a common multiplier. Well, you're finding 3 times what equals 15. 3 times 5. So if I want to keep this equivalent, I got to multiply by a value of 1. So what has a value of 1 that has 5 in the denominator? 5 in the numerator, 5 over 5. So in this gets a little bit more fun, is we have to see, and what am I going to multiply 2a to get 18a squared? Well, I got to multiply it by 9a. 2 times 9 is 18, a times a is a squared. So I have to multiply the numerator by 9a. So that common, so this becomes 45a. And so this fraction is equivalent to this fraction. And that's what we're going to do. We'll do that about 40 times. 3 times what is 18? 3 times 6. So 2 times 6 is 12. That is an equivalent fraction. 5 times 4. 3 times 4 is 12. And I talk to students. Students are so intimidated by fractions. And fractions really are quite simple. You just have to know your multiplication, because that's all you're doing. When you write an equivalent fraction, you're just multiplying. That's all it is. Kids are really intimidated. It baffles me. I get it. I struggled with math. But I think if it's taught properly, then we can get there a little bit easier and build that confidence and teach students that it is actually quite easy. So here they get intimidated by this. Oh, there's 2 terms up there. You're still doing the same thing. You're multiplying by 4. The only thing you have to remember is that Chewbacca gets in there. So that's 4 times x minus 2. Which is 4x minus 8 over 12. That's the equivalent fraction to that with a denominator of 12. So times 3, we just got to remember, distribute that out. 3 times 2n minus 3 over 15 equals 6n minus 9 over 15. So what are we multiplying? 15 times, what's that, 6? And then x. So we're going to multiply it by 6x, which is 48x. And we'll see. I don't know if it's going to be in 6.4 or 6.5. 6.5, we're going to get 2 fractions that we have to add with different denominators. And we have to find a common denominator. So that is going to be 3a squared, which is 15a squared, would be the equivalent fraction to that. That's going to be 6x. 6x gives us 6x squared. Yeah, we're going to blow through this. This is going to be so easy. 3mn. 3mn is 9mn squared. Okay, all right. So we ask, what is this missing to become this? Well, it's missing this term. So what do we do? We need to multiply this by n plus 4 to get this. If we do that, we get that denominator. So we have to do that to the numerator, because this has to be an equivalency, so it has to be a value of 1 that we're multiplying. 6 times n plus 4, which gives us 6n plus 24 over n minus 1 n plus 4. We don't factor because we tend to cancel that. That's not our objective. We want a different denominator. So we're going to get things that can simplify. That's going to be x minus 2. So 4 times x minus 2, which produces 4x minus 8 over x plus 2x minus 2. It's a horrible minus 2. We're going to multiply it by x minus 1, 2x minus 1, excuse me. So that's going to give us 6x minus 3. We're going to multiply it by x minus 7. Well, that's interesting. So 5xy minus 35y. We always want to put our variables, when we have multiple variables in a term, we want to write them alphabetical order. All right, so we might want to factor this just to be able to see what's the difference between those. So it's just multiplying by 4. So that's also a very interesting. So we want to factor out a 3, and you get 2x plus 5. So what's the difference between those two is timesing 3. We may even have to factor the left side. We'll see if they get that crazy. So this is the difference of squares. So what's the difference between those two? Is going to be the x minus 2. So I'm multiplying that by x minus 2. I get 3x minus 6. It's going to be in the numerator. Difference of squares. What's this missing that this has? It's missing that x plus 1. X plus 1, you get 4x plus 4. Here's, oh, all right, good. So I'm going to write this as this, and then I'm going to write it like this. And now I'm going to, and I'm going to factor, and I'm going to rewrite this, and I'm going to factor out this. And now I can see much better what does this have that this, what does this have that this is missing? Well, it's just missing the y. So if I multiply this by y, I get that right term. So I'm going to multiply that by y. And my answer is 5y. You can't do that without factoring, looking, making sure. So there is a couple steps that you will need to do in order to ensure, whoa, x squared plus 2x, and then I'm going to factor out the x, and I get x plus 2. So factors, remember, is multiplication. So what am I multiplying to get? So I got to multiply this by x, and I get 3x squared. That's what that's missing. Or that's what produces that right term. LCD, remember, C is for common, and L is leftovers. We should be very proficient at that. We would do the prime factorization. So we look at our denominators. 4 is 2 and 2. 6 is 2 and 3. If we want to find the LCD, we circle what they have in common. They have a 2 in common. And then we circle what they have left over. The leftovers are 2 and 3. So my LCD, my least common denominator, is going to be 12. So that's my, well, let's do this, equals, we'll put that as 12 and that is 12. And now we have to write equivalencies. So we have to do what we just did in the 20 problems before. So we have my starting fraction in, I'm converting it into 12. So times 3 times 3. So 1/4 is equal to 3/12. And then I'm going to do it to my other term, 5/6 equals how many 12ths? And I'm going to multiply that by 2, multiply that by 2, and I get 10. So those are equivalent fractions to those two. They have like denominators. Well, let's do 2 is 2, 8 is 2 times 2 times 2. LCD common is 2, and the leftovers are 2 and 2. So my LCD is going to be 8. So let's make them into eighths. 3/8 is 3/8. We don't have to convert that one. So we're going to multiply by 4, and we get 4/8. Yes, you should be able to do that mental math, but we're just showing the steps. So now we have 3 terms that we have to find the LCD. So 2 is easy, 5 is easy, 4 is easy. So LCD, what do they have in common? They have nothing in common. But the leftover is going to be interesting. So we're going to do this as a common, this is a common, and this is a common. So 2 times 2 times 5, which is 20. So these aren't separate. If you can double up from 2 of them, you should be able to do that. You're allowed to circle that. So that's a little bit technical. So common denominator of 20, and we have 3 seconds equals how many 20th times 10 is 30. 2/5 equals how many 20th times 4. These are techniques that are built in, I guess, 5th and 6th grade. They shouldn't have to be addressed in 7th grade, and they sure as heck shouldn't be addressed in 8th grade. 3, 9, and 6. 3, 9 is prime factorization. 6 is 2 times 3. So common, they have a 3 in common. They have a 3 left over and a 2 left over. So the LCD is the 3 that they have in common. The 2 and 3 is left over, and that's 18 as a common denominator. 18, 18, 18. So 2/3 equals how many 18ths times 6 is 12. 5/9 equals how many 18ths times 2 is 10 18ths. And 1/6 is equal to how many 18ths times 3? 3 18ths. I mean, this is a great, this is a skill that is so important. It's important in so many ways for later on math. They have nothing in common, so everything is going to be a leftover. Everything is leftover, so this is going to be a big one. 2 times 2 times 2 times 5 times 3, which is 8 times, well, that's 8 times 5 times 3, which is 40 times 3, which is 120. 120, don't know how many students would be able to see that 120 was the least common denominator. So that's why that technique right here with the prime factorizations is very efficient. That took me 10 seconds, 20 seconds to find the common denominator. And now we can go back to here and we can think of how 8 times what is 120? Well, there's my 8. What did I also multiply to get that 120? So 5 times 3, so 15. I know that it's 15. So we can utilize that information also. 25, 75. So 75 1/20ths, 2/5 equals 120. So we again can come over here and here's my 5. So I still have my 8 and 3, which is 24. So I know I got to multiply by 24, which is 48. 48 1/20ths. So there's where the work, showing our work, helps us also. 4/3 equals 1/20th. I know that's going to be 40, and that's 160. So that one we didn't need to utilize the prime factorization. 3, 4, and 9. 3, 4, and 9. And again, nothing in common. We can circle one of those 3s. That's left over, that's left over, that's left over. So my LCD is going to be 3 that 2 have in common. The 2, and the 3, which is 9 or 6 times 6, which is 36. So my common denominator is going to be 36, 36, 36. 2/3 equals 36. That's going to be times 12, which is 24. 3/4, 36 is going to be 9, which is 27. And 5/9. 5/9 times 36 is 4, which is 20. All these problems are still being done, completed in less than a minute. So let's keep to this. Oh my goodness, there's variables. Oh my goodness, it's not harder. First steps, same first steps. Let's look at the prime factorization of the denominators. 2, 2, 2, and 3. LCD. What do they have in common? They have a 2 in common. And then they have a 2 and a 3 left over. So my LCD is going to equal what they have in common and then the leftovers, which equals 12. LCD is 12. So I'm going to write an equivalent fraction. So we're going to convert these to twelfths. And I take a plus 2b over 4 equals how many twelfths? 4 times what is 12? Times 3. The only thing here is we got to remember to introduce Chewbacca. So that's going to be 3a plus 6b. So 3a plus 6b, because we have to distribute it into both of the terms. Let's take the other one. 2. Ooh, I don't like that. I'm going to rewrite it. I'm going to be a stickler. Minus a plus 2b over 6 equals how many twelfths? We're still going to multiply that by 2. Multiply it by 2. We get negative 2a plus 4b. Negative 2a plus 4b. The answer key probably doesn't have it. It probably has it 4b minus 2a. I don't like that. I think that that's very inconsistent. We should stay the course. Show consistency. Prime factorization, you should be able to do these super fast. They have in common, and then we have leftovers. So my LCD is going to be what they have in common, leftover, leftover, leftover. So that is 60. 6 times 10 is 60. We're going to write it as a fraction in 60ths. So n minus 2 over 12 equals how many 60ths? That's times 5. We're going to do 5n minus 10. And once we have common denominators, now we can combine their numerators if we were adding or subtracting or doing whatever we're doing. N plus 3 over 15 equals 60. It's going to be times 4. 4n plus 12. Yeah, you want to build this confidence. If you can be this good at this, you're going to see algebra as much, much easier. 3 times 5, 2 times 2 times 5. They have in common leftover, leftover, leftover. LCD is 5 times 2 times 2 times 3, which is 5 times 12, which is 60 again. 60ths. N minus 1 over 15 equals 60 times 4. So 4n minus 4. And then we have n plus 3 over 20 equals 60 times 3 times 3, 3n plus 9. 3n plus 9. Now, we didn't talk about this. You know, there are other common multiples. If we don't pick the least common multiple or denominator, there's nothing wrong with it. We just will have to simplify after we add and subtract. That is a certainty. So just least provides us smaller numbers. We're working with smaller numbers. We always like to work with manageable numbers. When we get big, then it makes it a little bit harder. So there are advantages of writing and using the least common denominator opposed to just any random common denominator. So my LCD is 24. 24. Excuse me. 2x plus 3 over 12 equals 24. So we're going to multiply by 2. And that's going to give us 4x plus 6. We have x minus 4 over 8. We're going to multiply by 3, which gives us 3x minus 12. Can't wait for section 6.5 when we start taking this to the next level. 25, 20, 2 times 2 times 5. Those are common. Those are leftovers. 5 times 2 times 2 times 5, which is 25, times 4, which is 100. So 100 is my common denominator, and x plus 2y over 25 equals 100. Multiply that by 4. So that's 4x plus 8y. And we have 2x plus y over 20, which is times 5, which is 10x plus 5y. Hopefully you feel confident at this point. You go, okay, all right, I remember when this used to be hard, but now it's easy. Now I can do this. I can see the work and how systematic it is, and all I'm just doing is repeating these steps. And I'm not really doing anything more challenging than just multiplication, right? So this will be good. We'll utilize our prime factorization. We are not going to factor this yet. Later on, no, not later on. No, we're not going to factor this. We still have x squared minus x minus 6 over 21 equals 105. So what times 21 makes 105? Well, there's my 21, so I have to multiply it by 5. So I'm going to multiply this by 5, and I'm going to multiply everything. So that's 5x squared minus 5x minus 30. So it wouldn't benefit us to factor the x squared minus x minus 6, because we got to multiply it by 5. And we want to keep that as a trinomial. X squared minus 9, even though that's the difference of squares, over 35 equals 105. So what produced 35? 35 was 7 times 5. So I got to multiply it by 3 will give me 105. So 3x squared minus 27. Good. All right. Ooh, throw some variables in there. 3t, that's an easy prime factorization. 9rt squared, that's not hard. 9 is broken into 3 and 3. R is R. T squared is T times T. They have a T in common. They have a 3 in common. And then my 3, my R, and my additional T are my leftovers. So LCD is going to be what they are in common times their leftovers. So that gives me 9RT squared. My other term right there. 9RT squared. 9RT squared. We already know that that's going to be the same. And so the only one we have to convert is that 9RT squared. Now we can go back and still use this. We can look, okay, here's my 3t. Here's my 3t. What am I multiplying to get 9RT? I'm multiplying these 3 terms. So I'm going to multiply it by 3RT. 3RT, which gives us 6RT. So this is 6RT is the equivalent fraction. Hopefully you see that. XY, prime factorization, y squared. This is what they have in common. These are the leftovers. LCD, y times x times y. Least common denominator is xy squared. Xy squared, xy squared. I'm going to take 5xy is equivalent to what? Xy squared. Let's multiply that by y, which gives us 5y. 6 over y squared. 6 over y squared equals what over xy squared? That's just multiplying by x. So that gives me 6x. M squared n is m times n times n. M n squared, m n n. They have an n in common, an m in common, and the m and n is left over. So LCD equals m squared n squared. right? M, N is what they have in common, M, N as leftovers. So that's M squared, N squared, M squared, N squared, and we have 11 over M squared N equals what over M squared N squared? Let's multiply by N. 11N, 17 MN squared equals what over M squared N squared? We're going to multiply that by M, 17M. Okay, so we are going to factor this. Why am I going to factor it? Because I want to find the factors, pairs. We're breaking it into its factors. So of course I'm going to find a common factor. Of course I'm going to factor this out. So when I do the prime factorization of this, that equals 2 times x plus 5. And when I do the prime factorization, I do 5 times prime factorization 5 times x plus 5. We can't break up the addition. So when I look for the LCM, I see that they have that in common. And then the leftovers are 2 and 5. So my LCD is going to be 2 times 5 times x plus 5, or 10 times x plus 5. That's going to be my denominator, 10 x plus 5. 10 times the quantity x plus 5. And now when I find equivalencies, I'm not going to write the 2x plus 10. I'm going to write the 2 times x plus 5. So when I need to find its multiplier, what am I multiplying? I can easily see I'm multiplying by 5 to get 15. Super, super easy. Much, much more logical, and you can see what it's missing to make an equivalent fraction. 5 times x plus 5 equals 10 times the quantity x plus 5. What am I going to multiply by? 2. So I know that that's going to be 2x. Yeah, that's a good one. All right, so a plus 1, the prime factorization is a plus 1. A minus 1, the prime factorization is a minus 1. They have nothing in common, so these two are leftovers. So my LCD is going to be a minus 1, a plus 1. So I'm going to write 2. I got to find equivalent fractions. And so we write 3a over a plus 1 equals a plus 1, a minus 1. What's it missing? It's missing the a minus 1. A minus 1. So we get 3a squared minus 3a. So a little technical, but still the same exact steps. If you watch the steps from the first problem, I'm doing the same exact thing for the steps later on. A minus 1. We have a plus 1. A minus 1, what are we going to multiply by? A plus 1. A plus 1, that's 2a plus 2. 2a plus 2. Good. Couple more. So I'm going to factor that. That's going to be conjugates, difference of squares. So I get a minus 2. A plus 2, prime factorization is that. And then we have a plus 2. So they have that in common. And this is a leftover. So I don't have to write it twice. I know my LCD equals a plus 2. That's what they have in common. And a minus 2 is my leftover. So a plus 2, a minus 2. A plus 2, a minus 2. And now let's do equivalencies. Well, that's the same thing. We don't have to do anything because that's the denominator. And then the numerator is going to be 5 times a minus 2. Can you now do, hopefully now you see what is this missing, and we can start doing mental math. So that's 5a minus 10. Can you start seeing what things are missing before instead of writing it out? If this is the difference of squares, we know what it's missing. So that's a 5, that's an a minus 2. And 5 times a minus 2 is 5a minus 10. So we can start looking and seeing. Now, I would do this. I would definitely write out its prime factorization, but I can tell what the common denominator is going to be. Common denominator is going to be x times x plus 3 times x minus 3. And that's where we're getting to for high school. By the time you get in high school, you should be able to do this. You should see, and now we can look and see, and that's going to be x times whatever it's missing, x minus 3. So it's x squared minus 3x over x times x plus 3, x minus 3. That's horrible. And then what's this missing? That's missing. You take what is in the numerator and you multiply it by what it's missing. So that's 2x squared plus 6x over x times x plus 3, x minus 3. So that's where we progress. So that's going to be n plus 3, n minus 2. So we already see what the common denominator is n plus 3, n minus 2. N plus 3, n minus 2. We know that that's not going to change. It already has the same denominator. What's this missing? So we take the numerator and multiply by what it's missing. So my common fraction is going to be 7n minus 14 over n plus 3, n minus 2, n minus 1 doesn't have to change because it was the common denominator. We'll factor that. A signs are the same, plus 3, a minus 2. So we're going to have, a plus 1 times a minus 3 over a minus 3, a minus 2. That's the same one. That doesn't change because it was the common denominator. And then we would multiply that up. We would create, that's a squared minus 2a minus 3. Could you multiply that binomial that fast? Hopefully. And what was that, a minus 5? A minus 3, a minus 2. So we just did that. We again show that we're constantly doing these in less than 60 seconds. All these problems should continue. That type of efficiency is paramount. Good luck.